Good day, everybody. Today we're going to look at using the priority method to do the apportionment for divisor methods. So one way is to actually do the division and look for the right divisor. But what's usually described in many official documents is something called a priority method. So here's one from 2000, and they go through and describe the method and some of its benefits, history, and so on and so on. Scroll a little through here. So formula and practice, getting the priority values. So what that is going to entail is whatever number of seats a state has, for the priority to get the next seat, you're going to divide the state's population by the geometric mean of what it currently has to what it wants to get to. Right? So if a state currently has 10 seats, you would divide the state's population by the square root of 10 times 11. So you divide by the square root of 110. Now dividing by the square root of 110 is the same as multiplying by this value right here. So they look at it as a multiplier. I usually think of just dividing by, so it's where you're actually at n minus 1, and then to get to n, you want to divide by the square root of where you're at times the next integer. Anyway, so that's the multiplier, or yeah, I guess that's the multiplier. And then there's an example where we just look at 3 states from their population from, what was it, 2000. We looked at California and its population right there, 28,000, that's not going to change. New York and its population, and Florida and its population. So we're going to do these priority values. So again, this is really to get to 2, that means we're at 1. So to get to 2, I have to divide California's population by the square root of 1 times 2, or divide by square root of 2. And dividing by square root of 2 is the same as multiplying by 0.707, and so on. And then if we were at 2, to get to 3, you want to divide by the square root of 6. If you're at 3 and you want to get to 4, you have to divide by the square root of 12, and so on. Or multiply, they have the values there. And so multiply California's population by all these priority values. We won't need them all. We went a little beyond where we need to go. I should say multiply California's population by all these multipliers, and you get the priority values. Similarly, and these are the same multipliers as up above. The only thing that changed now is the population. So to get to 2 seats, you have to divide by the square root of 1 times 2, and so on. And similarly for Florida. So once you have that, let me do it where I can cross off. So again, here are the, well, there's the multipliers, which we won't use. So once you have these priority values, you just look. So you look at among all 50 states. In this example, though, there's only 3 states. So each state by law has to get 1 seat. So every state has gotten 1 seat. And now to give the second seat, who's got the biggest priority? California does, 21 million. So I'm going to give California a seat. I'll cross this off. So I've given California a seat. So California gets the 4th seat, and it now has 2, right? So there were 3 states, they each had 1 seat. So the house size was 3. but we just gave out the fourth. California now has 2. All right, well, let's go to the next highest priority. What do we got? We got 12,181,000, 12,729,000. So that's the next highest. So New York gets the next seat. So I'll give New York a seat. I'll cross this off so I don't use it again. And you see New York got the 5th seat, and it now has 2. And there was the priority for New York. Now who gets the 6th seat? So who's left? We got 9 million, 7 million, 12 million. So California gets a seat again before Florida. So I'll give California this seat now. So California got the 6th seat right there. Its priority value was right there. And you can see Florida will now finally get a seat, 9 million. So 9 million is the biggest priority of what's left, right? So these seats have been given. So we give Florida a seat now, cross that out, and so on. So Florida is now up to 2. We've given 7 seats, and you keep going in this way until you reach, if you want to give 30 seats, it'll take a while. Let me jump ahead to 25 here. So after we've given out 24 seats, we've actually given out 12 to California, 7 to New York, and 5 to Florida. And so then that's 24. So then the 25th seat is going to be given to New York. There we go. So New York gets that 25th seat. And verify it as what they have down here. New York got the 25th seat, that one right there. And then it'll be California gets the 26th seat. If we look at the biggest priority among who's left, 23, 21, and 2389. Well, that was a little bigger than Florida. So California got the 26th seat, and I'll jump ahead, and then the 27th seat would be here, Florida. And you keep going in that way until you give out all 30. So that's the priority method. Where are we? There's 26 for California, 27 for Florida, and a few more seats, but I won't do it. But so you just go in order of priority. One thing I wanted to stop at 26 for, that's a nice value. If you look at the priority from to give out that 26th seat, my divisor for the Huntington method has to be smaller than this value, but bigger than this value. So any number in between these two will make it so that using rounding with the geometric mean or the Huntington Hill method, that divisor will work. So you can actually see what divisors will work if you do the priorities. So we've got those values right there. So here I put the 3 states, and I'm gonna divide. So first, if I use the standard divisor, I get these 3 values, and my rounding would be too much. So this would round up, this would round up, this would round down. That gives me 27. So I can't use the standard divisor as a divisor for the Huntington Hill. But if I pick any value smaller than that number and bigger than this number, so right now I have a number that's smaller than that number, so I need to go bigger than 2374. So 2374. So let's just go, let's go kind of in the middle, I guess. Let's go 80. That should work. And these are the values we then get. So obviously this rounds up, but this will now round down. I have it automatic. But 5.4617 rounds down. If we want to double check that, but so 5.6. So right here, 5.4924 is where we would need to be to round up. So we're obviously below that, so we round down. And again, so if you do the priority method, the last priority that worked or that you used and the next priority that would give the next seat, those two values, anything in between there can be used as a divisor for the method you're using. And you can do priority methods not just for the geometric mean, but for any mean. Like for example, if we do it for the Webster's, one way I like to do the priority method with Huntington Hill is you kind of already know you're going to get the lower quota. So if you just, so this is with the 2020 population. If I just find the standard quota and then go to the lower quota, this is where all the states are at. Now every state has to get 1, so I probably should give the 1 now, but it'll work out. It'll rank. It'll give those division by zeros top priority anyway. So every state got its lower quota, and now I divide to find its priority. If this is where the state is at, you take the state's population and divide by the square root of this number times the next integer higher. So 6 times 7, 42, divide by square root of 42. This population divided by that gives me that number, and so on. Oops. And then I can just rank at this point the states in order of priority. Right, so notice at this point, if you give everybody the lower quota, you've only given out 410 seats, so you have more to give out. So let's do it based on the rank. So here we go. So I have to give out 25 seats, I think. So let's do it in order of increasing priority, and we'll assume no state goes above its upper quota as well. So I'm somewhere around here. Let's see. Actually, close. One more seat to give out. So there we go. So Minnesota was the last state to get a seat using the Huntington Hill. The next state would have been New York. It was really close to getting one, but didn't quite. But those are the states that got the seats. And every divisor method, Adams, Jefferson, Dean, Webster, you can do a priority. I'll just look at, say, Webster. So here is Webster's. Take the standard quota, just round down. You know every state will get at least its lower quota. And now for the priority, once again, you divide the state's population by, but not the geometric mean of the number and the next number, but the arithmetic mean. So you just take the mean of where you're at and where you're going to go. In this case, 6 and 7. The arithmetic mean is 6.5, so I just divide the state's population by 6.5, or divide this population by 0.5. That one you can see, this is just doubled. And so you get the priority that way. So if you just divide the state's population by the mean, whichever mean you're using, where you're at and where you're going to go, that gives you the priority. and then you can sort by priority, assuming every state gets at least its lower quota and not above its upper quota. Otherwise, you can still do priority, but not as simply as what I have here. All right, so here's in order of priority. 410 seats given out. We need to give out 25, of course, same as before. And it's 3 too many. So now you can see Minnesota was the last state to get a seat using the Webster's method. And Texas would have been next if you had 436 seats and so on. That's one thing about the priority method. You can see, well, if we had 437 seats, Texas and Florida would have each gotten one, and so on. 438 would be needed for Arizona. But that's with Webster's method. So give out the seats that way. Change it back to alphabetical. And you get the same apportionment as if you find the divisor. And of course, any divisor between that what was last used. Let's see here. So I could have used any divisor from between these two numbers for the Webster method. For Jefferson, I'll go to 2010. And so with rounding, you always round down with Jefferson. So that means, where you round up and down is given by the lower quota plus 1. Right? So you round down if you're below the lower quota plus 1. And you round up otherwise, but it's impossible. Right? So so that's how you would find the priority. You divide the population by lower quota plus 1. And again, everybody with Jefferson's method does get at least their lower quota. So in 2010, you've given out 414 seats. And if you do the priority of everybody, I did it for everybody, I won't need these values, but I give out 19 now. But then you have to calculate a new priority. Just because the state gets a seat, you can then calculate its priority again, right? So California got a seat, went 52, and this was its priority. And now that it has a seat, it's at 53, and here's its priority. It's actually the highest of what's left, right? So all these other states went down. It rearranged the states. They're arranged in order of this first priority. But California and Texas, once they get a new seat and you recalculate their priorities, they're still pretty high. And in fact, they're above Virginia's priority. Virginia would have been next, 669, whereas these are at 69 and 68. Actually, some of these states are even above that. And in fact, actually, even after California got a 53rd seat, it's next to get another seat, although that didn't happen. But so 435, that was the end. But if there were 436, I think California would have been next. Let's just double check that, right? So California is the next highest, 6, 7, 8. Because, I mean, there's nobody else, yeah. Florida almost would have gotten it, but no. Well, I guess I can look here. So, if there were 436 seats, California would have had a real quota violation there. But anyway, so that's how the priority method works. It's more complicated. Similarly for Adam's method, but there, since you're under the lower quota, you got to start on the other side there. It's more complicated. But priority methods work for any divisor method. And again, if we look at this fictional country, you can either use the divisor method or the priority method. You look at the population, you give the lower quota, you assume you'll get the lower quota. Find the mean of where I'm at and where I'm going to go, divide the population by that mean, and that gives you the priority. And then the largest priority, in this case, you only need to give one more seat, gets the next seat. For Huntington Hill, population, everybody got their lower quota. Find the geometric mean of where you're at and where you're going to go, divide the population by the geometric mean, largest value got the next seat. And you can see the range of divisors that would work. Well, actually you can't because you don't see the next priority. So similarly here, population, lower quota, harmonic mean of where you're at and where you want to go, population divided by the harmonic mean, largest value gets the next seat. And I didn't do it with Jefferson or Adams, but all right, so there's the priority method. Last topic is why the different methods, what they optimize, and what's really best.